Hello, everyone. Today is November 16th, 2022. This is the Kubernetes Data Protection Working Group meeting. So today we just have some updates on the CAP status. We don't have a lot, but of course, if you have any other topic, always feel free to add it on the agenda. So Yvonne, you want to talk about CBT first?
Yeah. It's likely going to be a short update today. So yeah, since we last met, I had a chance to chat with Jan and James about like the CAP. So they Jan and James they were the folks who have been providing some feedback on the CBT CAP as well as on the CSI API PR that's associated with this CAP. So the TLDR there is James that he liked the idea that we included the the flow control, the API server flow control mechanism as a mitigation strategy within the CAP to regulate the amount of request and response flowing back and forth Kubernetes API server and the aggregated API server. But it is hard to argue with the concern around the number of requests and response that happen. I don't know if you folks have a chance to see the most recent threads in the working group channel. So even if we take a volume of 1 terabyte, which is not uncommon, and then we say the block size is about 512 kilobytes, and then we make assumptions around okay, maybe one response will return 10,000 CBT entries, which is what AWS EBS do, just plug in random numbers that we can find what is out there. We're still talking about thousands of requests and responses, right, flowing between the backup software through the Kubernetes API server and then finally to the aggregated API server. And it's likely that this request and response whether we reuse the existing TCP connections and do some streaming there, it's still likely going to trigger some sort of spikes on the Kubernetes API server end. They have all these SLO metrics that will start firing off when there's a tremendous amount of spiking the request and response within a very short period of time. So yeah, then so we kind of chat this started floating ideas around to see how we can handle this. One thing that Jan was talking about was is it possible to export the CSI RPC directly to the user, so bypassing the Kubernetes API server, so it just end up being gRPC protobuf a request and response between the backup server and the CSI driver. The main concern there is though the main concern there is as we all know to date CSI hasn't been used that way. And it has a very different versioning scheme. And unlike the API Kubernetes API where there's alpha, beta, GA, the user has a certain expectations on what directly accessible endpoints and APIs and how they are versions and how they'll deploy. And we look around we just don't see besides CBT or maybe potentially change file tracking that follows. We just don't see there are any other CSI feature will require exposing a subset of the CBT direct. CSI RPC directly. So there's one alternative that we just talked about, and then James also brought up the idea of what if we use we still deploy an aggregated API server, but we implement some sort of permanent redirect request response, some type of exchange, send a 300 kind of back to the client, and then redirect all the subsequent requests to another endpoint directly, out of an endpoint directly. So that didn't work because, as you folks might remember, like the newer Kubernetes API server, it now reject like all like redirect response from aggregated API server in response to a CVE that was filed back in September. So yeah, just like kind of the recent chat around that.
Hey, Ivan.
Positive feedback. Yeah.
Yeah. The records are supposed to be extent based, right? So you'll only get, so if there's, if multiple blocks that are contiguous get changed, you should get one record back for that extent. So your worst case is every other block got touched. And that's your absolute worst, because otherwise, like if every block on the disk gets touched, you should get one extent back that covers the entire disk.
Would that be provider specific? I don't know if it's I mean, like we can update the CSI sidecar to be more intelligent that way.
Certainly we can collapse them together, but that was the design for the records, was that it be extents, not just blocks.
Yeah, I think at one point like we did bring this up in the very early design draft. In the I think like that would mitigate part of it. I mean, again, I think it's something that we definitely can account for. Like you said, in the worst case scenario, it would still be like every other block, like and then like we still maybe from like a 2,000 request response, we go down to we half it to 1,000 because
well,
so
that's your absolute worst, and very few applications are going to touch every other block. And it's also like how much time was there between snapshots, but you can assume, but you can take the worst case is the boundary.
Yeah, I think like the worst case is the key concern here, and and the because like the other thing that I brought up in the Slack thread is also like do we, at least for alpha, do we want to like add a specify like a threshold on the volume size, like a 1 terabyte, like because if it's like a 10 terabyte, 100 terabytes, it will still continue to like grow in an unbounded fashion, right? And like that 512 of kilobyte block is also arbitrary too, right? 512 kilobytes is what AWS EBS use. I don't know about like for example VMware.
It's a lot smaller actually in VMware, but you're really looking at worst case scenario is worst case scenario, but you get more benefit on larger volumes, because just you can't write 100 terabytes in a reasonable amount of time. So if your backup is taking place like once a day, even you usually don't expect to write more than 10% of the volume maybe, and it's going to tend to be in extents. So it's not going to be completely randomly distributed, and it's not going to be like one block. It's not going to be like a million one blocks that aren't contiguous.
This is a worst case, right? The first snapshot will be the case.
Well, yeah, and it depends, right? Because like, for example, if you wrote all of the data on the first snapshot, before the first snapshot, and you wrote the entire disk, that should come back as one extent.
Yep. Again, this is the worst case scenario. I guess it's hard to argue that.
So the worst is you manage to write every other block between snapshots, or at the beginning of the before the first snapshot.
Yep. Ivan, I have a quick question. So regardless whether or not the end of the day we choose to implement a Kubernetes native API or not, CSI itself, it's agnostic to Kubernetes. Should we take the route of having the API defined in CSI firstly, and then we can think about Kubernetes implementation? Of course, this is a very important use case, but looks like this can well be two things that serves the same purpose, but facing different platforms. I can imagine if it's available in CSI, backup vendors can actually go ahead and implement the service by themselves instead of going through the API server route.
I think, Shanqing, when you submit a PR in CSI Stack repo, the reviewers there want to see the end-to-end workflow. They want to understand that.
Yeah, but this is a legitimate kind of, is a very legit workflow, right?
Yeah, but they normally want to see how this is used in Kubernetes, actually, or any other container exchange. They want to see example. That's why normally when someone just submit a CSI spec, you see reviewers asking how this is used, and then normally then we get point them to a cap.
Not like a service built in a generic environment in any container.
But this has never happened. The CSI is very much tied to Kubernetes now.
Okay. If this, I mean, I was thinking now,
we have seen those cases, right? Yeah, there are some PR submitted without a cap to start with, and then they're asked for something that is like a cap.
It is just to me that there are restrictions in Kubernetes, right? Whether it's resource size or API server,
even if we do not,
etc.
So right?
Yeah, but let me finish, right, please.
Yes.
So there are restrictions over there. Sometimes we cannot bypass, and we will be facing pushbacks from the Kubernetes community, talking about concerns over security, concerns over load. Doesn't matter how you do paging, etc., etc. Now the issue is the CSI is supposed to be kind of platform agnostic, and it's a very legit use case. Otherwise, vendors will be forced to talk to or bound to a vendor-specific API to do backup workflow. So yeah, I was just thinking now, if you feel that,
I understand. I think definitely what you said makes sense. But I actually have a very recent case. Well, I was trying to promote a very small feature to GA in CSI spec. It got blocked just because we have not figured out how to use that field in Kubernetes as a first class field. It's not like it's actually used in Kubernetes, just not a direct field in TVC itself. Then for that reason, it got blocked.
Okay, cool, thanks.
Yeah, we have for what it's worth, like we already have like a PR into the CSI spec on that front. So yeah, like if at the end of the day, like we're just gonna get asked like okay, how do we expect the users to use it? If they use it directly, I think that's like one of the main concerns that James pointed out. If they use it directly, like how we version currently, the RPC spec is different from typical Kubernetes API. But yeah, like for what it's worth, the PR is there. And then I address all the feedback so far. I guess like yeah. I guess Dave, to your point also, like I think it's like being able to do having some sort of extend mechanism to chain or like combine like blocks into like one or fewer. It's something that we can definitely add to the cap. I guess like yeah, the follow-up question there is like because like we have to make assumptions, right, or like the volume size and like the block size, and there's just a little bit of feels like there's no predictability there. Like once we said this is okay, even though it's alpha, once you push it out there and release it, and people put it.
Well, there's a minimum block size, right? I mean, the absolute minimum block size is pretty much 512 bytes.
Mm-hmm. So like like that would be.
I mean that, but we can collapse that. Like the CSI driver can certainly collapse things together. It can look for extents if it's getting back like a stream of bits even. And I'm writing a note for the channel, but I just thought I'd toss it out here. Is what we really need. There's only the actual data that we need is 1 bit per block, written, not written. That's all we need. So
sorry, 1 bit per block.
1 bit per block. That's all that's really required is, was this block written? Was this block not written? So you could compress the whole thing down into 1 big bitmap, and that gets you like 256K per terabyte.
You still need the block location.
Nope, because you give the entire bitmap. That's the entire bitmap for the disk, right? Every 512 byte block, 512K bit. Yeah, so a 1 bit map for the entire disk saying which blocks are written. So no addressing information because you get the address by the offset in the bitmap.
Different systems have a very different implementation of block size. So
I understand, but I'm just saying that so start from what is our absolute minimum data required.
sure.
Right. So it's
Okay.
1 bit per block. That's what we need. And so we could, for example, chunk that. So we could chunk the disk into multiple regions and give back a bitmap per region, like if we gave back even say 1024 records, right? That gives us 256 bits per record, or 256 records with 1000, 1024 bits per record, 1024 blocks per record. So that's an option too.
So what does the I guess like I'm not able to envision what that bitmap looks like. Is it like, so in my mind maybe
It's a bitmap. So say for example you have 1 byte and you have 8 blocks, right? Bit 0 says whether block 0 got written or not. Bit 1, block 1 got written or not, etc.
So that will still continue to grow. Is that not the case? Like depending on
Nope.
like the
No, because what we're tracking is not how many changes, but just if it changed. So it can only be so the binary case is didn't change, did change. Doesn't really matter how many times you write the same block, it still did change.
Sorry, this will certainly save space, right? So if you think about bitmap, what Dave was trying to say is that you don't carry any block location information. You just purely based on indexing and decide whether this block has been marked as dirty or not in the
Right.
in between 2 snapshots, right? Well,
and that's your absolute minimum. Everything else is just optimization and syntactic sugar around that.
Yeah, there will be concerns on this as well, Dave, I bet. One
there's always concerns.
There will be performance issue, right? Because to your point,
well,
right, in between 2 snapshots, you might well see only like maybe, I don't know, 50 blocks changed. If
that's
it's
right.
very frequent.
So for example, we can break this down though. So each record could cover like a gigabyte or whatever, pick a number. But so we can have a record per, say we did record per gigabyte. That's 1024 records per terabyte disk maximum. And you just skip records where there were no changes. And if there's at least one change in that segment, then you get back the 1024 bit mask.
You're talking about map. You're talking about map of map, basically.
A list of maps. A list of bitmaps.
Yeah.
So it's gonna be a sparse list of bitmaps.
It's gonna be very challenging for all the storage vendors to implement that. But I agree with you.
I don't see why. I mean, that's the basic structure underneath most of these things is just a bitmap.
You need to populate all this and conform with their format. I mean, it's definitely gonna just save space.
Yeah, it would definitely. I mean, if the concern is going to be the amount of records returned, and it's the worst case, but we can deal with the worst case. But if we just went to returning a list of bitmaps, potentially sparse list of bitmaps, it'll be considerably small. It's still a large number of records. That's why and even with 1,000 records, we don't want to put 1,000 records into the API server per snapshot. But bandwidth wise, it's pretty tractable.
Right. So like the bitmap, the number of blocks on the bitmap, or the number of bits on the bitmap is still dependent on the total volume size, right? So,
yes.
So like you said, we can still potentially talking about like lots of requests and response flowing back. within a shorter period of time, regardless of how much the payload is and the bandwidth requires.
Sure, but we're looking at 256K per terabyte minimum.
Right. I think like yeah,
Or
I think like
actually that's a max. Well, that's at the 512. The 512K byte blocks.
mhm. So I think the concerns are still like twofold, right? Two points, right? Like in addition to the payload bandwidth required, but it's also like the request and response that it has to happen between
But
to carry those
even
data back.
but even if you can reduce the payload, then the pagination can be in effect much larger, right? So in this case, it actually will reduce the number of requests as well.
Yeah. So
If-
I'm thinking,
Yeah.
like in this case, it'd be like 1,000 record. We could just pick. Well, yeah, at 250. So there's 256. There's 256,000 512K byte blocks. So pick however you want to split the disk up. You could split that 1 terabyte into 256 records, right? That's 1,000 blocks per record.
Is that enough? Yeah, typically a block size is like a couple of kilobytes.
Yeah, so we can talk about that, but even that, so even if you multiply that out, the data payload is still relatively small per record. So it's definitely under like the 1 megabyte per record.
Sure, we can do a quick practice over here. So let's assume.
So say you go to 1K blocks, that's a gigabit. Right? So gigabit over 8. So it's 256 megabytes if you do 1K blocks. Right?
Per byte?
Right. So no, I'm talking bits. So if you have a terabyte volume, so you have one gigabyte or 1 billionish blocks, right?
Mm-hmm.
And then if you go 1 bit per block, then that's divide that by 8, right? Which is 256. Math working anymore? No, it's 64. Wait, damn it. 128. I used to have all these embedded on the inside of my head, not anymore.
Yeah. So
128 megabytes.
Yeah. $128
And if
probably
you-
add on pagination,
Yeah.
maybe.
Well, and then you could break that into 128 or 256. If you break it into 128, right, that's 1 megabyte per, that's.
Yeah, I agree with you. It's going to greatly reduce the payload as well as number of requests because it's more condensed.
Yeah, and that's absolute worst case, right? So absolute worst case is every other block got written, or even, well, actually in this case, I guess if every block got written, you'd need to return a bitmap per. Yeah, it works better in the worst case, and in best cases, you return more data, but it may not matter that much. You're more likely to get the full amount of data because it's more likely that you would write 1 block in every across the entire disk so that you hit every big segment. But there's probably something clever we could do in there too. So we could do like extents or something. I'm going to think about this a little bit more. I'll toss out some ideas on the Slack channel.
We also need to include some minimum metadata. If it's a sparse list of bitmaps, then you also need to carry the index, which byte
but
this represents.
But versus a megabyte versus data, it's going to be like an extra, 512 bytes.
It's going to be double, right? At least double. Because each byte you will need a corresponding thing.
No, you just need the starting offset of the whole bitmap. you'd have a
The-
bitmap and you'd have a starting index, and then just
Right.
each bit is offset from the initial index.
Right, the offset is like at least has to be integer, right?
No,
And then
no, but it's just for the block of bits, though.
sorry, I misunderstand you. If it's every other block, how do you do that? You will need
1 0
to
1 0 1 0 1 0 1 0 1 0.
So we basically map up the entire volume.
you
Yeah,
use
you get-
okay.
Yeah, because it's cheaper to do the bit off to do the implied offset than it is to actually write out all the offsets. It really it's optimizing for the worst case rather than the best case. Because in the best case, you have one block that changed somewhere on the disk, and you can represent that with one address and length. But your worst case, every block on the disk changed, and so if you have to have an address and length for each of those, it balloons. So we probably want to wind up somewhere in the middle with the format that works reasonably well in all cases.
So once the backup software or the user got back the bitmaps, like so like they would have to like deduce like the location of the blocks based on the bits, right, on the map.
Yeah, so you just look at the offset. I mean, you can calculate an offset into the bitmap and multiply that by the block size,
Right.
and then add
And then,
that to your initial offset.
Right. Then the data mover part would be the one that is trying to like locate like
Yeah, I mean, that's all internals, right? It's like we figure out what blocks are going to move and we push it out somehow. But that's a problem we already had.
Mhm.
So it's really just a matter of getting that block list. So what we're really looking at is concerns that the block list is going to be too large. Getting it back through the CSI/API server.
Yeah.
Because once it's on the other side, we have to deal with it no matter what.
Yeah. I think that sounds feasible. I mean, the only like I don't know if it was how common or how corner that particular case. It's like as you might recall, like some APIs like they rely on like things like data token to get the actual data box. So with the bitmaps, like the data mover
Oh,
pod,
right, that one.
yeah, they would be
You're right.
confined to one particular type of this is exactly how you're going to use the bits of
Yeah.
the map. Which
No,
I mean,
that's a
like,
good point.
yeah, I guess it's really depend on like which one is the common and which one is the corner case, really. So I'm okay with like, hey, like for phase 1, we don't support data token. It's a future problem. So I don't have for me like the bitmaps approach seems like reasonable to me. At least that's my perspective.
Yeah, I think we can at least start from there. It's like that is the absolute minimum amount of data delta the token, but that's the minimum amount of data that we need is 1 bit per block.
The end of the day is the storage vendors needs to implement that. So whether their internal system can represent the system like that, I'm not sure, because this is the major concern, right? So this actually requires them to label or have a internal kind of a sequential identity of each blocks in the system.
Well, I mean, I know vSphere, we wound up with a bitmap down there because it's compact.
It is for sure has its own value and very elegantly implemented. It's just in today's modern system. If they're using like UUIDs to as a block identity, then this is kind of hard to implement for them.
Shouldn't be, because at some point you've got to have a sequential list of blocks because that's how the device works. And
sure. Is like
as long as you can diff the 2 snapshots and say, yeah, block 5 changed, block 7 changed, block 99 changed, you can build a bitmap.
I am not disagreeing with you at all, Dave, on this. It's just how lower level that mapping is happening, right? If it happens very low in the stack, then it requires them to expose those out, and sometimes it's just not realistic for them.
Well, no, I mean, we can certainly take an existing API and convert it. So, like if we took, say, the AWS API, the real pain there is the token.
Tokens also,
right, but
yeah. So Dave, when you said
but you take the token out of the mix, and it's just you're converting a list of extents into a bitmap. It's not that hard.
So Dave, when you said like vSpheres, are you referring to like stuff like VADP and
So under VADP, right down at the bottom level, there's change block tracking is implemented inside of vSphere, and that's for the on disk, not on, but the standard, quote unquote, standard vSphere snapshot, not the ones that the array does directly. But yeah, there's basically a bitmap down there at the bottom, because it needs to be compact, because otherwise you wind up with taking too much, taking as much space for the extent for the change block list as for the actual disk. So
yeah. I think like I'm just trying to think like if we're at a point where we can say, hey, we're just gonna. It feels like yeah, yeah, like there will always be concerns depending on which storage providers you ask. Like I guess to Shang-Chen's point also, like I think AWS EBS they use their own logical index, which may or may not necessarily be the index on the block or on the disk. But like I wonder if we're at a place where we can just say, hey, like we want to like focus on this particular kind of pattern that we know enough providers out there we'll work with enough providers implementation. I guess at this point personally I just don't have that like data to say but I think like this bitmap approach is definitely very simple. It's simple in the sense it's easy to reason about from an API consumption perspective as well as an implementation perspective. So.
Yeah, I'd say we at least think from this side and then see how we can condense the format down. We need a little bit more information than 1 bit possibly, but we can think at least in terms of how much more do we need.
Okay. Do folks have on the call have any other thoughts, feedback on this?
So it will be CBT server's responsibility to calculate that bitmap, right?
Yes. So it's basically the format we're returning. So either, so the initial proposal was a list of extents, which is pretty good in the average case, honestly. But there's some concerns about the worst case. But it's just the format that's being returned.
It's the driver
the storage
to this, right? Actually, it's the CSS driver. Each CSS driver will have to implement this, actually, right, Dave?
Yes, because I think it'd be what we passed from CSI, but yeah.
Right. I was just wondering how many CSS driver can implement this.
Actually, we could even, well, honestly, given a list of extents, I can build a bitmap pretty easily. We could even implement this at the in the Kubernetes side. It's really not hard to take a list of extents and build a bitmap, as long as they're in sequential order.
It is, if it is sequential order, yes. The issue is that when it is not in sequential order, then no.
Well, but we pretty much need to get it. So somewhere it needs to wind up in sequential order, I think, because usually you don't want to.
Again, I'm not disagreeing on this at all. It depends on how the storage vendor's internal implementation is. If they need to expose very low level APIs, maybe not.
No. But weren't we assuming already that we were going to get back the records in order? They weren't coming in random order.
How do we guarantee that? How do we enforce that?
I don't know, but we were expecting that, weren't we? I mean, I think that's how all the offsetting and everything else would work, wasn't it?
Okay, then there shouldn't be any like parallelization per se. You have to call this one by one, right?
Well, you can call with an offset.
Then it defeats the purpose, right? How do you build the global bitmap without maintaining that sequence order? You need to sort all the blocks. Is that how it works?
It doesn't have to be global. I mean, if you say to me, give me a bitmap starting at offset X, and I can say, okay, give me records starting from offset X in order, I can build the bitmap easily.
Oh, that really depends on how. Yeah, again, hopefully everybody returns the blocks in a sequential order so that appending to that bitmap is not.
Weren't we assuming that in the old in the current API? I didn't think they'd come back in random order. I thought they were defined to come back in sequential order.
If it is, yeah, if it is, sequential, that's great.
Yeah, in the current at least in the prototype that we did, we didn't make any assumptions about whether they're random or sequential order. We just whatever the storage layers give it back to us, we just pass it back to Kubernetes.
But we could offset into it, right?
Yeah.
So I think there's
And
two ways this is typically implemented. One is a journaling technique, and then it might be hard to get them in order without some post-processing, say in the CSI driver. The other way is copy on write technology, basically, where you maintain a bit per block anyway, and when you duplicate the block, you set the bit. So then they're stored directly as bits. So in general, I think it's pretty workable. The block size needs to be specifiable. 512 is going to be way too small for current implementations, I think.
Yeah, 512 bits or 512 bytes, yeah.
Yeah.
And actually specifying a larger block size just means we have to collapse more stuff together. So if you said the minimum thing you're going to get through this API is a 512 kbyte block, you can do that with smaller block sizes. You just have to collapse them together, right? So if you had 512 byte blocks really down on the device you're getting back, you'd have to just take the 1024 bits and you OR them together, and that's your answer, right? So if any one of those blocks change, then there's a change to the 512 kbyte block. So you could specify a minimum block size, and it's relatively easy to implement, no matter what if the base block size is smaller.
I think we should definitely try Dave's method, right? There are some details needs to be flushed out, but this sounds pretty promising from my perspective. If the main concern is really about payload plus number of requests, if we can compact this in a way to extreme where we think we can get agreement from the many storage vendors that's kind of doable, or maybe we can either, to Dave's point, implement this by ourselves via some library. They can just code this library by themselves and expose in CSI. I guess this is going to greatly reduce the number of requests as well as the payload. So now it's really up to us to make it flushing out how to capture all these cases. The token one, I have no idea. That one is a real one.
Yeah.
Is that a token per block or is it a token per request?
It's token per block.
Damn. The block itself is like a 4K.
Yeah, unfortunately.
No, the EBS blocks are pretty big though, but what size were they?
EBS can be flexible.
But it doesn't go small. They're really big blocks.
Uh, 16K. Is that not that small?
Is it?
Yeah.
In the change block tracking though.
Yeah, in change block tracking is 512K.
512K.
Yeah, you have to look at
Oh.
the EBS direct API, not the EBS API.
Oh
Apparently,
crap! They don't use the same block to identify a change block.
They use a
No.
different set of API. And the fun fact, like EBS direct, they actually charge you per call. So
Yes.
Okay.
the thing is like 0.007 cents per call per API call. So
Okay, it says actually so. EBS advertises 512 byte sectors to the operating system. So yeah, 512 is this.
5K.
Yeah.
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 Yeah, I think like if like say for like 1 terabyte volumes, and then we can fit like potentially fit the entire bitmap into like one response, I think that would be like gold. That would be great. And then yeah, I think like now it becomes that I think like the rest potentially like the CPT sidecar can be the one that stitch all the raw response together and then present the bitmap. Possibly like we said already, we're probably not going to cover like every single implementation out there, providers implementation out there. But if we can get to even like 80% of the use cases out there, I think that would still be a very big win for us.
It's not a strong argument, I would say, right? Because typically people want the API to be open enough. But I really think this sometimes it's just the vendor limitations plus Kubernetes limitations. So
yeah. And then we got sandwiched in between.
Yeah.
And I know I'd argued for like the tokens originally, but thinking about it in this context, so if you, for example, clone the volume and you're reading blocks from it, the tokens don't matter. You just need to know which blocks to read.
Yeah, I think like
it's only if you're actually going to the EBS Direct API, and in which case you've already written an EBS Direct dependent piece of code anyway. You could just go to EBS for the change block tracking as well.
Are you?
Yeah.
I'm afraid they will use the token to do some checksum calculation, or even.
But if you're but if I'm reading from a block device, the token there's no way to pass the token down, right? So I just need to know the offset to read.
Sure. Do they have that kind of API to allow you to go to that offset and read?
Yeah, you clone which is what we currently do, right? You snap, clone, attach.
Oh, I see. You just just completely kind of make a new volume out of it. Okay.
Because that's our data path right now, right? In a strictly Kubernetes standard data path, the only way we can get data out of a volume is by attaching the volume to a pod and reading it. There is no other data path that's defined.
Yeah, I feel like that is a generic enough approach that you can just tell users, hey, this is how it's going to work. You have to restore the snapshot and then use those bitmaps, that information that we give you, to complete the rest of the data path. Yeah, I think like data token is just like future thing. Anyways, cool. Okay, I think like I think we have enough information to decide on what the next step prototyping is going to look like.
Sorry.
Cool.
Sorry, this unfortunately how open source community works. Everybody got a say. Right? Well,
No,
it's good. It's a very good discussion though.
Yeah, no, I think it's great. I think that's part of what make Kubernetes great, right? Like everyone get to share ideas, and we choose and pick what is best for the community at large. Okay, I think like that's it for now. And then I'll maybe chat with some of the folks to see what the potential next prototype is going to look like, and so stay tuned. Okay. Xing, back to you.
All right, thanks, Ivan. Okay, so hold on. We should going back to So there is this a new cap that is merged in 1.26. I just want to bring this to everyone's attention. This is the provision volume from cross namespace snapshot. As you all know that when you create a PVC from a volume snapshot, right now it has to be in the same namespace, but this new cap allows you actually to provision a PVC in a different namespace from the original volume snapshot. So, well, the actual implementation actually changed a little bit after this cap is merged, but at a high level, this will require this this reference grant CRD. Currently, this is a Alpha CRD under gateway networking. So there is some discussions on moving this one to SIG auth because it's a bit weird for us to depend on a networking CRD. But this one basically allow you to say, hey, let me transfer this snapshot to be used by this PVC, which is in a different namespace, right? So you see this one, right? So there's a grant, there's a reference grant. So from this persistent volume claim to this volume snapshot. So there are two namespaces. There's a production namespace. There's a test namespace. And I think this is the place where it's actually got changed. So if you remember that, I believe folks here are all familiar with how you provision a PVC from a volume snapshot. There is a data source field. This is for volume snapshot, and previously there was a data source ref field that is added for the volume populator. Does anyone on this call use the volume populator at all, or has anyone implemented it in their product or has done a POC using the volume populator? No?
Yeah,
Huh?
I've done.
You have? Okay. Sorry, I just want to check who is talking.
Abhishek.
Oh, Abhishek. Oh, okay. This is for which project?
OpenEBS.
Oh, okay. Yeah, I remember there was a blog about that. Is that still alpha feature in OpenEBS? Do you know?
Yeah, it's in alpha only.
Okay, yeah. So I think that yeah, that was the use case I think we look at when we move that field to beta. But there are not a lot of adoption yet. So when this new proposal for cross namespace provisioning got initially, they're proposing to add another field called data source ref2. So if you look at the cap, that's what it was proposing, to add another thing called a data ref2. Then that means there are like 3 data source fields in PVC spec. So when they submitted this PR implementation, there were some new comments asking them to actually just to change the existing data source ref to a so from a local object reference to a object reference. The local object reference does not have a namespace field, but object reference has a namespace field. So because this is still beta and also adoption is not that much, so basically now we'll just have this new field, well, same field, just the type will be a little different because now it has a namespace. Previously, it does not. Now,
question.
Yeah.
Maybe this is something you already discussed, but since this is I'm sort of new, I wanted to ask: do we plan to use the same infrastructure or maybe a different infrastructure to allow also multi-namespace attachment of PVCs, not just from a snapshot data source? For example, a shared file system. If a user wants to have has a PVC pointing to a PV and mounts that with like NFS or something like that, and then he wants a PVC and pods to be able to access the same data source, just like a read-write many volume from another namespace today. It's sort of
So like provision
only
PVC from another PVC, and then which is from a different namespace.
like using the same PV with different PVCs for
Oh,
like
different
multi PVC namespaces, like multi
that's a
namespace
little bit.
PVC.
You're saying like bind to how do you say that? Are you talking about like multiple PVC, the same PV, or like a multiple?
Yeah,
PVC
the same
sharing the
physical
same
volume.
Oh no,
would
that's
be,
not that's not addressed by this one. No, yeah, so that's
but,
still PVC to PV. That's still one-to-one binding.
yeah, I know, but like we see customers and with I'm from NetApp, and for some of our customers latest release of our CSI driver, we sort of work our way around that, but since a PVC is a namespace object, and since there's a one-to-one binding, if you have an NF like a shared file system, sometimes sometimes customer users would like to mount the same data source, since it's a shared file system with several namespaces in that cluster.
Okay.
And then today it's impossible. You can do that with static provisioning, but they like to work with the CSI features, and they don't like to use static provisioning. So I was wondering, because maybe this infrastructure can be used to point not just to a snapshot, but maybe to a different PVC in another namespace or something.
Yeah, that's probably possible. I actually don't. I forgot how if this would work for another PVC. I need to check that part. So I will add a note there. That part was originally kind of not in the original proposal, but I think when there were a lot of changes when this one got implemented. So I think there were some restriction got removed. Initially, like this data source ref field only allow a auto-tree CRD as a source. You can't use like anything in tree, another PVC or something, but I believe that got removed. But let me double check on that. So basically what you want is, let's see. So I'll just add a question here. You're just saying provision, create PC in namespace 1 from another PVC in namespace 2?
Yeah, precisely.
Okay, I need to check this one. I do not remember because initially we were saying that will be too complicated. It could involve secrets and things like that. So we decide to just limit this for the snapshot case. But then, kind of now combine these two together. I actually need to double check this one. I do not know if there is any like restrictions in the implementation part. So yeah, let me double check on that and get back to you. Right. So now this one right now, so it's not going to be affecting this data source field, right? I know a lot of you already have used this field in production for the bottom snapshot, create PVC from bottom snapshot. So this will always be there because this is already GA field. It's going to do some there was some logic to copying from this field to this new field, and also from the new field back to that field if the new field does not have namespace specified. But this field will always be there. So right now you don't have to make any changes to your code. But I just want to bring this to your attention because this might be useful. Now this is a alpha. We're actually still implementing this in the sidecars external provisioner. That's still ongoing. But once it's there, you can try it out and see how that works. Eventually, when this goes GA, then you could also use this instead of this existing field because it's going to be equivalent, right? Once this one is ready. But if you want to keep this, you can always keep this. This will always be there. Is that clear? Is there any? I thought this might be interesting, right? So I think there are a lot of use cases for this cross namespace. transfer.
And this is also where that reference grant is going to come in to enforce the reference
Right.
permission,
Yeah.
right?
This is
So what's the plan with the reference grant? Are we going to go
yeah, so
ahead
that's
and
still, yeah, so that's why I was saying, watch, just keep an eye on this one, but don't rush to implement this in production, because this is we are doing alpha, and then we're depending on this. Also, this is alpha CRD in networking. There is some discussions with SIG-auth to move this to SIG-auth, so that looks more like a common API. It doesn't make sense for like storage APIs to depend on a networking API. And also, this is it's not a core API even, right? So if it's a core API, it's fine. This is a CRD. Sometimes you don't know if they are making any changes, and suddenly it's not working anymore. So yeah, so we want this one to be moved to some common place before we move this feature to beta. Yeah, so but right now this is just for alpha. This is well, it's coming from. It's a alpha gateway API. Right, so user will have to do this reference grant. So it's not like they can just use this directly, like their provision, directly provision a PVC from a volume snapshot in the same namespace, right? You don't have this extra step. This one we do require user to do this extra step. So this is just for the security reason, right? That we don't want this one be so easy. So they have to know this is you need to do this grant and accept, then allow this to happen.
Hey, I need to drop. Yeah,
Okay.
thanks everyone.
Oh, sorry. Actually, we
I'll be
already
in touch.
passed time. Actually, thanks for reminding. I need to join another meeting. All
Alright,
right.
cool.
Great discussion. Thank
Thanks
you.
Bye.
everybody.
Thank
Bye.
you. Bye.
Bye.
Yeah.
Bye-bye.
Thanks, folks.